packet, and in this video we are going to learn how to use the determinant to find the area of a triangle. If you have a triangle that has the coordinates 3 ordered pairs, A, B, C, D, and E, F, we can write that as a matrix. So we're going to start our matrix by listing the ordered pairs. So here we've got the first ordered pair, the second ordered pair, and the third ordered pair. So you write it in that order. And then we're going to make it so we can find the determinant. So what we do is we fill in our matrix with ones. So you fill in that third column with ones. Okay, then we're going to find the determinant. So just like we learned in the last video how to do that, so we're going to use the determinant of our matrix. So we have to find the determinant to be able to find the area of the triangle that is represented. If you recall from before, you have learned previously that the area of a triangle is equal to 1/2 times the base times the height. And that is fine as long as you know what the base is and what the height is. And if you don't know either one of those things, and if you don't have a right triangle, it's a little bit harder to do because you have to find out what's the height and what's the base, and you might have to use the distance formula or some other formulas to find that out. But we can use the matrix to do that whether we know it's the right triangle or not. The area of a triangle is also equal to plus or minus 1/2 times the determinant of the matrix. So that the lines around the A, that means that it's the determinant of matrix A. And then the plus or minus is there because we're going to use whichever one, plus or minus, will give us a positive result. So if the determinant is negative, we would multiply by negative 1/2. And if the determinant is positive, we multiply by positive 1/2 to get our area. So let's go ahead and look at an example. The first example, example number 2 in your notes, we've got these 3 ordered pairs, 3, -4, 2, 3, and 0, 6. So you first need to start out by writing the matrix. So I've got the matrix started with my 3 ordered pairs. So here again I've got the first ordered pair, the second ordered pair, and the third ordered pair. It's very important that you write it in that way. Okay, then we're going to fill in our matrix with ones. So now it's a square matrix, and so now we can find the determinant of that. So we're going to rewrite the first 2 columns, and then we will find the determinant like we did in the last video. So we're going to do the series of multiplication and addition and subtraction. So let's go ahead and do that. So 3 times 3 times 1 is 9, -4 times 1 times 0 is 0, 1 times 2 times 6 is 12. We're going to add all those together. Then we will subtract 0 times 3 times 1, which is 0, 6 times 1 times 3, which is 18, and 1 times 2 times -4, which is -8. When we go to simplify all of that, we get 21 from the first set of parentheses minus 10 from the second set of parentheses, which gives us 11. Now be careful that you understand that we're not finished. That is the determinant. But to find the area, what we do is we're going to use our formula. So we're going to do 1/2 times 11. Half of 11 is 5.5. That is the area of the triangle. Okay, just to show you visually what we just did, if we take the 3 ordered pairs and graph them on a coordinate plane, so I've got the 3 ordered pairs graphed here, and if I connect the dots to make a triangle, what I'm trying to do is I'm trying to find the area of my triangle. So this shaded region right there. So we would need to count up how many squares were in there, and so if you did it very, very, very carefully, you would find that there are exactly 5.5 squares in that yellow region. So that's what we just did with the matrix. You can see that it's not a right triangle, so we would have difficulty finding the altitude in order to find the height of this triangle, and then we'd have to use the distance formula to find out what the base was. And so the matrix method is a lot easier to do, especially for a triangle like this. Okay, let's go ahead and do example number 3. So I've got this set of ordered pairs, so of course the first thing we do is start our matrix. So we'll write the matrix with the 3 ordered pairs. We're going to fill it in with ones, and then rewrite your first 2 columns. Okay, now we're going to do our determinant, so the multiplication process again. So 6 times 12 times 1 plus 7 times 1 times 11 plus 1 times 10 times 3. That we're going to find the sum of all of that. Then we'll subtract 11 times 12 times 1 plus 3 times 6 times 1 plus 1 times 10 times 7. So you should have that written down. You don't have to write all the 6 times 12 times 1, but you should write the 72 plus 77 plus 30. Especially because when you're going back and doing this by hand and you have to check your work, you need to make sure you can find where you make a mistake if something's not looking right. Okay, then we're going to simplify that. We get 179 minus 220. And that gives us negative 41. That is not the area. First of all, notice you cannot have a negative area. That doesn't make any sense. So when we use our determinant to find the area, we're going to take the negative 1/2 times negative 41 so that we will get a positive area, positive 20.5. We always label our areas in units squared, so depending on if it was inches or meters or whatever, since we don't know what it is, we're just going to say units square. Area is always units square. So make sure you write it like that.